Can you tell me if you ready? Oh. Right, the question here is saying prove the following identities. We are having two identities, sine 2x over cos 2x plus sine squared x is equals to 2 tan x. Then this is the second identity, 2 cos squared into 45 minus a is equals to 1 plus 2a. Right, as we do these identities, we can see there are some double angle identities there. So what we have to do, let's have some background information. We have sine, let's it be noted that sine of 2x is equals to 2 sine x cos x. Then we also have cos 2x. Cos of 2x is equals to basically it has three options. This one, the first one is cos squared x minus sine squared x. Then we also have in this one that is 2 cos squared x minus 1, and we also have 1 minus 2 sine squared x. So as you can see, cos 2x has three options, 1, 2, 3. Sine 2x, it only has 1. So the choice for you to use for cos 2x, it depends with the situation that you are having. So here we are now required to prove that RTP, we are required to prove that sine 2x over cos 2x plus sine squared x is equals to 2 tan of x. So in this case, I'm going to start for you from the left hand side. Then from the left hand side, can you see I have a sine 2x? Thank God for sine 2x. It has only one option. So which means here it will now be equals to 2 sine x cos x all over. Now here I have a cos 2x here. The option of for cos 2x, it will depend with the situation that you are having. Can you see here I have a plus sine squared x. So I will have to choose from 1, 2, 3. So the best option for me for this one is going to be the first one, cos squared x minus sine squared x. It is the best option in the sense that I have a minus sine squared, which will later on cancel with the plus sine squared that is there. So which means here I'll now substitute this cos squared x minus sine squared x for my cos 2x. Then here, then I say plus our sine squared x there. Then from there, can you see that now it's minus sine squared plus sine squared, which gives us here the denominator becomes 2. So the numerator, that is 2 sine x cos x all over cos squared x. Can you see that here? Minus sine squared plus sine squared is 0. So I'm left with cos squared on the denominator, which is now equals 2. If you look at this one now, cos squared cancels with one of the cos squared. Then I'll be left with 2 sine x over cos x, which is equals to 2 tan of x. It's proved. It's now equals to our right hand side. That is for A. That is the question for A. Then as we do the question for B. On B we are now required to prove that 2 cos squared into 45 minus a is equals to 1 plus sine of 2a. Let's separate them there. Right, as you can see, we need to prove this is equals to that. But look here, it's quite tempting for us to want to expand this using compound angles. In this case, that might seem to be right, but it will give us a problem because expanding it will be really a big thing. So can you see that here I have a 2 cos squared, which I have a 2 cos squared. Can you see here I have a 2 cos squared x. So the moment there is a 2 cos squared, it means we are dealing with a double angle for cos. So in this case, I'm going to make use of the fact that I know that cos of 2x is equals to 2 cos squared x minus 1. And in this regard, we are now saying if I make 2 cos squared the subject, it actually means that cos of 2x is equal, sorry, here it's plus 1. Sorry for that, it's plus 1 is equals to 2 cos squared x. But however, now this one looks like that one, but I'm not dealing with an x. My x is equals to 45 minus a. So which means if in place of x I substitute with 45 minus a, it means 2 cos squared. In place of x I write 45 minus a. We are saying it's equals to, coming here, it will now be equals to cos of open bracket here, sorry, cos, sorry, it will be cos of 2 open bracket 45 minus a. I'm now substituting 45 minus a for our x there. So let me put a big bracket there. So which basically implies that 2 cos squared 45 minus a will now be equals to, sorry, here is 45 minus a, which is exactly what we're having here, and we must say plus a 1 here. Don't get confused. The plus 1 is the plus 1 that we are having here. So which now becomes, it will be now removing this bracket, it will be cos of, there it will be 90 minus 2a plus 1. Simplifying this one, which is now equals to cos of 90 minus cos 90 minus 2a. It's like, can you see these are co-angles, co-functions of angles, which means it will be now cos of 90 minus 2a will be, in this case, sine of 2a. This becomes sine of 2a plus 1, which is exactly our right hand side in this case. So which means it has been proved. That is the best way to prove. So if I can repeat myself, we are saying the most important thing is when you see a double angle, you must really substitute them well. And in this case, don't be tempted to expand this part using compound angles, because it's actually a double angle for cos if you look at it very well. Thank you so much. God bless.